Hi everybody, so welcome to this next portion of the videos on flight planning. Here we have a E6B flight computer. So here we have the side which you do most of your calculations on, and decides for wind correction angle and ground speed. So we'll start on the flight computer side. So what you'll notice here is we have this small window here that shows pressure, altitude in thousands of feet, as well as air temperature in degrees Celsius. We use this left side here for converting indicated altitude to true altitude. Over here we use pressure, altitude, and temperature to calculate our density altitude. On the inner ring here we have time that could be in minutes or hours. And what's interesting about the E6B is the timer, even though it says 11 here, which could mean 11 minutes, 11 gallons of fuel an hour. So interesting here is just, correct, take that back. The inside portion is all time. So this could be 9 minutes, 90 minutes. This one could be 14 minutes, 140 minutes. So you have to adjust as necessary for your numbers to make sense. On the outside, it's all units. And you'll notice that the 60-minute mark has a special arrow, which indicates units per hour. So if we point to 60 at, let's say 12 right now. So what this could mean is 12 gallons an hour, 12 miles an hour, 120 miles an hour, 120 knots. It can mean a lot of things. Just remember, the outside is all units, the inside is specifically time. That's where most students get caught up. Okay, so one exception to the rule about the inner ring being time and the outer ring being units is the calculation of true airspeed. So when you do those calculations, the inner ring now represents your indicated airspeed, outside is your true airspeed. So with these parameters, we're going to try to find true airspeed. So we have a indicated airspeed of 74 knots, pressure altitude 7,500 feet, and a temperature of -5 degrees Celsius. If you're unsure what to do on your check ride or knowledge test, just read here on the E6B. It tells you exactly what to do. So what we need to do is set our temperature and pressure altitude and have them aligned with each other. So let's move it. So -5 is on the right side of 0, so we'll go ahead and move it over here. That looks like about 7,500 and -5 degrees. So now that's set, we're going to go out to the outer ring and look for where it says 74. So inner ring, I mean. So there's 74 knots right there. Going out, we have a true airspeed of 82 knots. And in here, you got to pay attention to temperature because it goes positive on this side, negative on this side. So oftentimes students will line that up backwards and get a really interesting answer. So with that, let's go ahead and work on some E6B problems to demonstrate how this works. All right, so now we're going to do some practice problems with using the E6B. So the first problem I have up here is, what is the density altitude if your altimeter setting is 008 inches of mercury, we have a temperature of 20 degrees Celsius, and then we have a field elevation of 1,000 MSL. So we'll go ahead and use the equation to find pressure altitude. We'll take 2992 minus 3008, close parentheses, times 1,000, and then we'll add our field elevation. And if you do the calculation, you should get a pressure altitude of 840 feet. So now this is where we take temperature into account. You're going to get your E6B, and what you're going to do is you want to take your temperature of 20 degrees Celsius, which is right there. You can see a small mark I made earlier. Line it up with 840 feet, which is just shy of 1,000. And then we'll look at our density altitude. And if you look there, this indicates about 1,500 feet. And just remember that the altitude in here is all indicated in thousands of feet. So for this one, our density altitude would be 1,500. All right, let's do another practice problem. So the next problem is this time we have a density altitude of 10,000 feet, and a temperature of 5 degrees Celsius. And this time we want to find the pressure altitude. So this time we're going to use the E6B again, but we're going to work backwards. So what we're going to do is I'm going to line density altitude up with 10,000. I'm going to look at the temperature where it says 5 degrees Celsius, which is right here, and go down. And if you look here, you'll see that it's around 9,000 feet pressure altitude. So the answer to this question is we're going to have a pressure altitude of 9,000 feet along with a 5 degrees Celsius temperature. That will give us a density of 10,000. All right, so that's enough of pressure altitude. Let's go over and do some calculations of time. Action. All right, so now we're going to do some calculations that involve